Go.
If Bob starts pushing 2 boxes for 8 seconds and then stops, how far apart are the boxes from one another? Here's your diagram that you are given. You're given A and block A, block B. Block A weighing 117 kilograms with a mu of 0.8. Block B weighing 33 kilograms with a mu of 0.5. And the force applied being 2,150 newtons. First step you'd have to do is to draw force diagrams for each block. Block A has a force, the gravitational force going down, and the normal force going up. The force applied, the kinetic friction of block A, and the force of block B applying on force A. Gravitational force is found by multiplying the mass times 9.8, and it is newtons because, as we look at our unit analysis sheet, kilograms times mass divided by seconds squared is kilograms meters per second squared, which is also the same as newtons. The gravitational force is always the same as the force normal, so it's the same number and the same steps. The kinetic friction is found by multiplying the mu value multiplied by the normal force. So the mu block A is 0.8, and it has no units because it's just mu, multiplied by the 1,146.6 newtons, which is 917.28 newtons. For block B, the forces are the gravitational force, force normal, the force of block A on block B, and the kinetic friction on block B. Gravitational force is found the same way as block A, and it equals 323.4 kilograms meters per second squared, or newtons. The kinetic force of B is found the same way as block A, by multiplying the mu value, which is 0.5, and multiplying by the normal force, 0.5 times 323.4 newtons, which is 161.7 newtons. The next step you have to do is to make sum of the forces equation. So for block A, it would be the force applied, because since the force applied is to the right, it would be positive, minus the kinetic friction of block A, minus the force of block B on block A, and these are to the left and negative, equals mass times acceleration. Block B would be the force of block A on block B, minus the kinetic friction of B since it's to the left. That equals the mass times acceleration. Using these two equations, we know the force applied, the kinetic friction on A, and the mass. We don't know the acceleration or the force of box B on block A. For B, we don't know the force of A on B, but we do know the kinetic friction of B and the mass, but we do not know the acceleration. So, in order to solve this like a system of equations, add the force of block B over. To get this equation, the force of block A on block B equals mass times acceleration plus the kinetic friction plus B. Substitute this equation in for the A equation, so you now get force applied minus the kinetic force of block A, minus, in parentheses, mass times acceleration, plus the kinetic force of B, equals mass times acceleration. Now you just substitute the values in for each known value. So the force applied is 2,150 newtons, minus the kinetic friction of block A, which is 917.28 newtons, minus, in parentheses, this is all block B now, 33 kilograms times acceleration, plus the kinetic friction of B, which is 161.7, equals the mass of A, which is 117 kilograms times acceleration. Now don't be fooled here, this minus implies this whole equation, so it would be negative 33 kilograms times acceleration, and this would be a negative 161.7 newtons. So when you simplify this out, you would add 33 to both sides, and subtract 2,150 minus 917.28 minus 161.7 to get you 1,071.02 newtons equals 150 kilograms times acceleration. Now all I have to do is divide by 150 kilograms to find the acceleration. Acceleration equals 7.14 meters per second squared. It is meters per second squared because newtons, as we said, is kilogram meters per second squared. And you're multiplying the second squared on the bottom by the kilograms on the bottom. And the kilograms cancel. There's 1 kilogram on top and 1 kilogram on the bottom, which cancel out, which leave you with meters per second squared. Now that you know the acceleration, you can find the final velocity of this situation using acceleration equals final velocity minus initial velocity all over time. We know the acceleration because we just solved for it, 7.14 meters per second squared. We don't know the final velocity. We can assume the initial velocity is 0, and we can divide this all by our time of 8 seconds. To get the final velocity, all you have to do is multiply 8 seconds, multiply by the 7.14 meters per second squared, and you get 57.12 meters per second. Since you're multiplying by 8 seconds, 1 second would be on the top, 2 seconds would be on the bottom, 1 would cancel from the bottom, and there would be no seconds left on the top, leaving you with meters per second. This is a situation when Bob is pushing the box, so this is not when they have stopped. So we need to draw another force diagram to show when he has stopped pushing the box, and the boxes are just sliding along their surfaces. So we have box A with its forces of gravitational force and normal force, which is the same as the last time, the last diagram, and the kinetic friction of box A, which is also the same. Block B is also the same with the gravitational force, normal force, and the kinetic force of B, which also has the same values as the previous. If we do our sum of the forces equation, we get negative kinetic friction of A, since it's to the left, equals mass times acceleration. And for B, it's the same thing, negative kinetic friction of B, since it's to the left, equals mass times acceleration. Our only unknown in this case is the acceleration. So as we solve for the acceleration, we do negative 917.28 newtons equals 117 kilograms times acceleration. And for block B, we have negative 161.7 newtons equals 33 kilograms times acceleration. Block A's acceleration would be negative 7.84 meters per second squared, and block B's acceleration would be negative 4.9 meters per second squared. Kilograms would cancel on the top and the bottom, just like in the last scenario. And a negative acceleration makes sense here because the boxes are slowing down and are not being pushed. Now again, we would use this acceleration equals final velocity minus initial velocity all over time to find the time of this situation, since you don't know how long it takes for the boxes to stop. So for block A, we have our negative 7.84 meters per second squared equals 0 minus 57.12 meters per second. Now where did this number come from? Well, we found that our final velocity when Bob was pushing was 57.12 meters per second. So when he stops pushing, the boxes are already going this fast. So that would be your new initial velocity for this scenario. And that would be all over time, since we don't know time. Multiply t by both sides, so with negative 7.84 meters per second squared times t equals negative 57.12 meters per second. Divide negative 7.84 on both sides, and you're left with 7.29 seconds. And you know it is seconds because it is meters over seconds, divided by meters, negative 7.84 meters, which would stay in the denominator. And on the top would be seconds squared. The seconds on the bottom would cancel. There would be 1 left on the top, and both meters would cancel, leaving you with 7.29 seconds. For block B, the acceleration is 4.90 meters per second squared equals 0 minus, again, the initial velocity being 57.12 meters per second, all over our unknown variable of time. Negative 4.9 meters per second squared times t equals negative 57.12 meters per second. Divide by negative 4.9 on both sides. You're left with 11.66 seconds. And here are again the cancellations. Meters canceling on top and bottom. Seconds canceling on the bottom. 1 second left on the top. Now that you know the initial velocity and the time, you can use this displacement equation to find the displacement of how far each box went. For block A, use our initial velocity of 57.12 meters per second times our time we found for A, which was 7.29 seconds, all plus 1/2 times the acceleration, which is negative 7.84 meters per second squared, which we found for A, all multiplied by our time, which is 7.29, as stated in the previous part, and squared. 57.12 meters times 7.29 seconds. There's 1 second on the top, 1 second on the bottom, so they would cancel, leaving you with just meters. 1/2 times negative 7.84 meters per second squared times 7.29 seconds squared, which is also another 7.29 seconds. There are 2 seconds on the bottom, 1 second here and 1 second here, so they would all cancel, leaving you with just meters. Your new equation would be 416.4 meters minus 208.32 meters, and that would give you the displacement for block A, which would be 208.08 meters. For block B, it is the same scenario. Your initial velocity times the time we found for block B, plus 1/2 times the acceleration we found for block B, all multiplied by the time squared. Seconds on the top would cancel from seconds on the bottom, leaving you with just meters. 2 seconds on the top, and 2 seconds on the bottom would also cancel out, leaving you with just the meters. And your new numbers for this scenario would be 666.02 meters minus 333.09 meters equals 332.93 meters. Now that you found the displacement for both blocks, you can subtract the two to determine how far away they are from each other. So 332.93 meters minus 208.08 meters equals 124.85 meters. And that is all. This is how you find how far two blocks are away from each other using the displacement equation.